We have seen how the pixel generation part of the frame buffer core is constructed. Now let's construct the whole core. So we have seen the code for this one already. All we have to do is just put a wrapping circuit in a blender, and we will create the whole video core. So before we actually construct the wrapping circuit, we need some sort of a register map. So here's a suggested register map. And just as a reminder, the buffer core itself is just basically a memory module that has several lines or rows, and each row contains information about a very specific pixel. And that's basically what this register map is showing. What this register map is showing is that the processor interacts with this particular frame buffer core by writing into it, and specifically it specifies which pixel location it needs. It specifies the X and the Y, and it just goes to write a 9-bit value. So the processor is going to be writing the 9 bits, and then the palette circuits is just going to change it to something else. Okay, so how does the processor actually figure out which pixel it wants? Remember, it's like the frame buffer actually contains a buffer, like the buffer is pixel information, and a specific value would have an X and a Y. Well, the driver is going to actually take the X and the Y, and it will construct an address that is consistent or consists of 18 bits, and that's what you see in here. So the A tells me it could be 0 and 1, and this is what matters. So we have 19 bits. And just as a quick reminder, this is how an address looks like on the address bus. Okay, so we have all of these bits in here, and just as a quick reminder, the least two significant bits, because we're dealing with 32-bit addressing, and this is just for alignment. Here, this is just the address of the bridge to activate the bridge, and here, because it tells me that I need a video core. And now this little one in here, it has been 0 for all the other video cores. Now we set it to 1 because we're dealing with the frame buffer. Remember, we dealt with the frame buffer as a different video core than the rest of the typical video cores, and the reason why is because we need the address bits in here to be a little bit different. So in the previous video cores, we have decided that we have 8 video cores, so we figure out which video core we want and which internal register of these video cores. We don't have that in here. We only have one frame buffer because that's the only one we can actually instantiate, and sometimes we can barely survive with it as well. So, or we can barely fit it in the FPGA chip. So if you count the number of bits in here, you're going to see that we use 19 bits. Now, what are these here? Basically, this particular one will be a pixel, maybe this one, and its address will be computed based on its X and Y, and the driver will actually do the translation. And that's how we have the register map. The last value in the register map, the very, very last one, is going to be used for the bypass, which is a little bit different than the other video course. In the other video course, we decided, I believe it was 0, I believe it was 0x, maybe 2000 or something like that in hex. Okay, but anyway, it's not the same as the other video course, so we can just do that. So the implementation we're going to see here in code just basically follows this particular diagram. So let's take a look at it in here. So what it does, it actually does instantiate. It's not the OST, it's actually just the pixel generation part of the frame buffer. Okay, and then it does the following. It does basically some decoding. So it figure out if the write enable, if I'm actually writing and actually the chip select is actually activated to this one, and if whether you're writing the bypass or a pixel, we know that the bypass is I'm trying to write into it, and all of them should be 1. If you're writing a pixel value, it's the write enable, and it should not be that last register that we use in here for the bypass. And then we know that basically what we're doing is this is how we do the wrapping circuit, and that's how the wrapping circuit is implemented, and that's what you see in here. Now what's happening in here, it's actually the blender. We don't actually have a blender. What we have is a bypass multiplexer. We're not blending because in the original design, this is the very first pixel generation core that we have, and whatever comes afterward gets blended with it. But this is basically the original one, so we don't need to blend. All we have to do is just figure out whether we want it or we want to bypass it, and that's what you see in here. So if you bypass it, you just basically take whatever input you have, and you're going to see shortly, or you can take a look at the code actually. I'm not going to show you that. It's pretty straightforward. When you instantiate all of the cores, or actually let me just show you those. If you actually go in here and you can take a look at the whole video subsystem, all of it, you'd see that the frame buffer is instantiated at some point here. That's the frame buffer, and what we have is we connect its SI input into this particular number, which is 008. It says it's a blue screen because it is technically 000 and a bunch of basically you can figure it out. I think it's that one, and then 000. It's in hex, so, and 0000, which is technically a it says blue here because that's a B. Remember, it's like that's R, that's a G, and that's a B. Technically, that's the G, but what's gonna happen is you're gonna see if you bypass this particular circuit, or if you bypass this, you will be passing this particular number in here. Okay, you're gonna be passing this all the way there, and you're gonna see a blue screen. Other than that, you're not gonna see a blue screen.